All right, everybody online can hear me and see my screen.
All good.
Awesome. And I am recording. Apparently, actually, was it this class I missed the recording on? Or was that 300? I think it was 300 last week. But it's up now. So there's two separate problems. Problem one was in my 300 class, I forgot to hit record. So everybody's job is to make sure that I always hit record before class. I rarely forget to, but better safe than sorry. 250 on Friday was recorded. I just didn't associate it with the playlist. So if you were on my channel, you could have gone and found the video just listed there. Now I associated with the playlist because another student couldn't see it. Because I always upload the videos right after class or within 5 minutes after class, but there I have to hit a little drop down and pick the playlist, and I must have just forgotten to do that. So I apologize. Okay, so today we're going to do something cool, and I created some starter code for us to walk through. So in our previous example, I decided that we want to represent these video game trading trading cards in our program, right? And so we created a little object that kept track of the name and the defense and the attack and all that stuff. We didn't do like a full on thing, but we did like a starting point, kind of giving us an idea of, let me just open up Eclipse here. Giving us the idea that, okay, well, if I want to represent a Hearthstone card, it's going to have a name, a cost, an attack, and a defense, potentially among other things. But this gets me my starting point for representing some real world object in my code. Okay. Now, I don't know the exact number of cards that are in Hearthstone, and there's other trading card games, Yu-Gi-Oh, Pokemon, whatever, but there's a lot of cards, right? So certainly what we don't want to have to do is we don't want to have to go through and handwrite all these. When we went into Maine and we created King Crush and the 4 different things, then we created another, I don't know, armor vendor or something like that, whatever it was, we created a couple cards. Probably don't want to have to do that for 1,000 cards or whatever the number is. Okay, so as computer scientists, getting data, where do we get our data from? Well, historically, maybe we would have had a file. So maybe you would have had an Excel document that had your data in it, or you would have just had a normal plain Jane local file. And we did some of that last semester where we just had a local file. But what if, so today when we think about this, so we can say maybe a local file. Like a comma separated value file, Excel, etc. Maybe a local database, MySQL, go a little bit older school, Microsoft Access. Another popular one is PostgreSQL. You might look at that in the web programming, the database 2 web programming class 460. So maybe it's a local tool for storing data. It could be a cloud database. So let's just add that here, local/cloud database. Or it could be through something called an API. Probably a remote one, but nothing says you can't create your own local one and then use it from your program. Okay, whatever. I don't know why this, maybe iCloud is having issues. All right, so what's an API? What can you tell me about an API? We've probably heard the term before at some point. Okay. So this is an interface. So application programming interface. Really, this is a set of, well, let's just deal with it at the high level. Talk to a web page using the HTTP language to get to work with data. So we'll say data is king. Same thing's true. I mean, we see this, you know, for when you put in your information on different websites, and there's sometimes a checkbox saying you agree that we may share your anonymous data with other people, things like that. Data is worth a lot of money. In fact, we have whole fields in computer science now dealing with data science, looking for visual trends and related to data. So this could be real-time data that updates. Now for us, we're saying, look, I'm creating an application that has a bunch of Hearthstone cards in it. I'd prefer not to have to write those cards, you know, hand write that stuff. And I also want to make sure that it stays up to date as new cards comes out. Now, I ask myself, might there be a source out there that allows me to grab information about these Hearthstone cards? And there is. Actually, Blizzard offers their own API for, you know, you're getting it right from the horse's mouth, if you will. But we're going to work with a different one because we're not going to get too far into APIs in here. But we want to get a big old string and work with that string. And that string is going to be in a format called JSON. So let me ultimately show you what we're looking at. So here is a website called API HearthstoneJSON.com/v1 25770 English US cards.json. And when you load this page, it gives you this wall of text. All right. Now, if you look at this a little bit closer, and I'll zoom in here, we see that cards actually have some information in them. So we'll walk through this a little bit. This opening square bracket says this is an array. It's a collection of things. This is a JSON object. This guy has an attack of 0, a card class of neutral, a cost of 0. I'm guessing this is some sort of ID in the database. A faction is alliance, health is 0. ID is art bot bundle 001, whatever that means. Its name is golden legendary, rarity is legendary. Set is, that's which set of cards it came from, and the type of thing is a minion. Lots of information about a card, some of which we might care about, some of which we don't. Okay, you go to the next one. Artist, card class, collectible. Here's another DBFID. All sorts of stuff. Okay. One thing we should notice here, though, is that inside of these square brackets, we have a JSON object, where a JSON object should look a lot like a dictionary to us, right? It looks like a dictionary to us. And we messed with JSON a little bit last semester, didn't we? I believe so. Don't recall. All right. Doesn't matter. Looks like a dictionary. All right. So this guy looks like a dictionary. But we are going to take the hard route of dealing with it in here rather than using a built-in library for parsing it, because we're computer scientists. All right. So this guy would be one entry in that collection of entries for cards. All right. Now our starting point is, let's get all of this stuff into our program. Well, we can copy and paste it and do something with it, but really what we want to do is we want to tell our program to read something from the internet. Bring this code into our program. Okay, so I've already put some sample code in here that does it. It doesn't take that much code, and we'll walk through this. All right, so you notice in the slides, the next thing we have on the list is to talk about the scanner class. All right, so the scanner class can be used to read stuff in from the user. So I'm going to give us a little example of that here real quick before we do this other stuff. So let's say I want to ask the user for a piece of information. I'll go ahead and create a scanner. I'm going to name it input. It's going to be equal to a new scanner from system.in. So when we build a scanner, we build it in terms of what input stream are we reading in from? So scanners, this is how we read data in from an input stream. Sample input streams, system.in. This is the keyboard. A file, a remote URL, web address, etc. Anything that we can attach a string to, anything that we think about in computers we might want to read from. Okay, we might want to have the keyboard, somebody type something in the keyboard and read it in. We did that a bunch last semester. So let's do that first. So when I create my scanner, I'm going to create it in terms of system.in. I want to scan from the standard input stream, which is the keyboard. All right, and we can go ahead and prompt our user system.out.println. Enter your name. I'll actually probably do a print so it doesn't kick it down the line. And then we'll say string name is equal to input dot next line. Okay. And we'll prove that we read that. We'll do a system.out.println. We'll just print out name, proving that we read it in by spitting it back out. All right, so we'll go ahead and hit play. It's asking us for our name. I'll type in Mike and press enter, spit it back out. Now, this is equivalent to us doing this in Python. That would have read in a string from the user in Python. So we can look at that and say, oh, well, Python seemed a little bit easier to just read something in. Well, it's true. But the other thing to consider is that Python, generally speaking, is a language built for doing a lot of command line stuff. We don't necessarily think of Python as the language we use to build graphic user interface games and things like that. Yeah. Which input? This guy? No, this is a tool. So I went to Home Depot and I bought a scanner. I named it input. I put a little label on it. It's called input. Then I used that tool right here to read something in from the keyboard. And the thing I read in, I put in this variable. This is main. What do you mean my original name? This guy? Oh, but this isn't associated with a variable. Forget about this. Forget about that this even exists for right now. Yeah, all we're doing is we're just introducing the scanner right now. I mean, this isn't a variable, right? This is a string literal that I'm passing into the constructor for Hearthstone card, which happens to use that variable called name, but the scope of this variable is inside of Hearthstone card, not inside of our main here. All right, so this is how we would have written it in Python. Python typically has a lot of command line applications you write stuff with. Java wasn't really designed for that. Not that we're not using it for that initially, but you know, that's the deal. So we want to read something in, we use the scanner. There's some older ways of reading stuff in using input stream readers and buffered readers and things like that. Input stream readers let us read in one character at a time. Scanner is kind of a more robust version of this. It did not exist in Java when it first came out. So scanner says, hey, here's kind of a power tool that we can pick up, and it lets you read from any sort of input stream. So we're going to see reading from the keyboard, and then a few minutes later, we're going to see it reading from the internet using the same tool. Okay. So I'll create my instance of scanner, reading from the keyboard. I'll prompt the user. You can say whatever you want. I'll read something in using the scanner's input.nextLine function. So this reads the next string from the keyboard in this case. And then I'll prove that I got it by spitting it out. And that's, so if I change it to Dave this time, it spits out whatever I typed in. Okay. Now, I'll go ahead and just change my prompt just for this example to say, enter your age. I'll read in my age. I'll print out my age. All I did is change some variable names here, right? So we're going to get the same thing. But now realistically, I might want to take my age and multiply it by, or add 2 to it, like that. Presumably, when I read in age, I want to do math with it. It's a number. Go ahead. Oh, sorry. You need to, it's probably in red squiggly. If you highlight over, here, I'll show you, this is what he has right now. So it shows it like this. If you highlight over this, it's going to say you can import scanner from java.util. So scanner lives inside of java.util. Is that one of the new M1s? Yeah, what do you think of it? And my parents, just got my parents one of the M1 MacBooks, and it's shockingly fast for being a different architecture because it's not Intel. I mean, it's their own silicon, so it has to map. In real time, you're running any application that you're running on there. Presumably Chrome has not been updated for the M1 chip yet. So most of you in the 325 class, right? And you're learning about computer architecture stuff in there. Well, the architecture of that Mac is different than the architecture of this Mac. My Mac has a Core i9 processor in it, Intel. Yours has an Apple M1 chip in it, which Apple makes, which is based on something called the ARM architecture. But all your applications that you have on there, or a high percentage of them, not made by Apple probably, were compiled for Intel. So that means that the operating system is having, or the processor is having to do a mapping between the instruction that's going to the processor saying Intel stuff into the equivalent instruction for the M1 processor, which is a big deal because previously when Apple did this, when they did a jump from PowerPC to Intel years ago, there was they actually had to run everything through a virtual machine that they called the blue box. Where now they're hiding that from you by just saying, just keep using your stuff. We'll fake it for now. And most of the benchmarks show that it fakes it shockingly well in terms of speed. End users shouldn't necessarily notice much, but like performance is still better than same machine with a different Intel processor in it. It's pretty interesting. So should be a pretty bright future, I think, for this, because that means that if it's this fast doing a mapping, kind of like Java does, right? How fast is it going to be once the applications have been written specifically for the M1 chip and you no longer have to do the mapping? So kind of cool tech. So in any case, I'm reading in an age. Now my presumption, I've mentioned that Java is a string-based language. So if we can get something into a string format, I can do anything I want with it. All right. Now, The squiggly thing he had here, we needed to import java.util.scanner. So the scanner class lives inside of the utility library of Java. And usually Eclipse will give you a little red squiggly, hover your mouse over it, it'll say, hey, this guy exists, go ahead and import it. All right, so we're gonna go ahead and read our agent, but we're reading it in as a string. So if age is type is a string and I try to add 2 to it, it's gonna just tack a 2 onto the end of that string. I'm not actually doing math, I'm doing concatenation, okay? Concatenation in Java, let's add it to the notes actually. We might have had it someplace else, but I wanna put it in here. Python required both sides to be string type. So if we wanted to do something like hello 5, we would need to do hello concatenated with string 5, like that in Python. Java, being a string-based language, which is my way of talking about Java. Nowhere is Java's advertisement saying, hey, we're a string-based language, but strings are super powerful in Java, so I want to keep highlighting that. So Java, being a string-based language, will allow you to do hello concatenated with 5, and that will give you 5. All right, so we can say that concatenation is a little friendlier in Java than it is in Python, but it's just, that's the rules it plays by. We saw in Python, it's just as easy to convert numbers into strings and stuff like that used in little string functions, so it's not the end of the world. All right. My habit is to always save, but it's not seemingly not connected to the internet, so I keep getting an error message from iCloud that it's not actually saving. All right, so when I go to print out the age here, it's just going to tack on a 2 onto the end of it. So if I put my age in there, if I put my age in here, it gives me 212 instead of a 23. Okay, now I have 2 options. Let's assume I really wanted to work with it as a number. I can read it in as a string and I can convert it to a number. Turning strings into numbers. In Python, I could have said age is equal to the int version of 21. And this would give me age as an int. So this is in Python. In Java, I can say age is equal to integer.parseInt 21. And actually this would be int age in Java. That would give me age as an int. So there exists a tool that lives inside of the integer class, and we're just getting ready to start talking about that static versus non-static stuff. We saw it last class, but we're gonna deep dive into it this week. So integer.parseInt is our tool that allows me to take a string that is a representation, a string representation of a number, and turn it into an integer, right? Same thing, a little bit different syntax. So over here in Java, I can say, well, you know what? I want to go ahead and say integer.parseInt of age to give me the numeric version of that age. And then I want to add 2 to it, which should give me now a 23. Okay. Similarly, I could say int age. In fact, I'll comment out these two things for right now. We're going to say int age is equal to input dot next int. We could actually ask the scanner to do the work for us. We can say, look, I'm expecting the user to give me a number. So I'm not asking it to give me the next string or the next line. I'm asking it to give me the next int. And it'll go ahead and feed you the next int. And now I can say system.out.println age plus 2, and I'll get the 21. Well, the 23 rather. That makes sense? Doesn't matter which of those you use. Again, we solve all of our problems in terms of the tools we have available to us, and none of us are gonna have the entire language memorized. We're gonna get pretty good at reading the documentation, and after we get into the static versus non-static stuff, we'll go and look at this. But we just want to see the highlight reel real quick. Parse int is the name of a function. We know it's a function because I see opening and closing parentheses here. I'm calling it with the name of a class. How do I know integer is the name of a class? Starts with a capital letter, probably the name of the class. Static methods are owned by classes. Non-static methods are owned by instances of classes. We saw last class when we looked at our Hearthstone card. Notice all our methods in here are non-static methods. Who owns those methods? Instances of the Hearthstone card class, like C1 and C2. So C1 can call his display method. C2 can call his display method. And C1 and C2's display method does not have static in front of it. It's owned by an instance of the class. If I go to the Java documentation, and I go to the integer class here, and we go down and we look at parse int. Here's parse int right here. It takes a string as a parameter. Notice it has static in front of it. What does that tell us? It says, if I want to use this tool, I have to call it using the name of the class. The name of the class this guy's defined in is a class called integer. So to use the parse int tool that lives in integer, because it's a static method, I say integer dot parse int. I call it using the name of the class in which that integer was which that method was defined in. Okay, that makes sense? Getting those two things down through practice is going to be important because it unlocks the entire documentation to us. Because now, if you, you're going to do Google searches and you're going to say, hey, like for instance, today we're going to start looking at some JSON data in a minute. We'll get it to the point where we're like, we have the data in our code. Now, what do we do with it? Okay, that's kind of our step today. You know, we want to create a zillion cards. We already have kind of a housing for holding our cards. We've created a class for our Hearthstone card. We don't want to handwrite all these cards, but we found a data source out there in the internet, presumably where I didn't even check how accurate the data source is. And I guess we possibly run into a problem where they have inappropriate stuff in there, but it looked fairly legit when I first glanced at it. Okay, but somebody out there has a data source. I'm going to go ahead and pull that data source into my program. So I have a giant string. Java, being a string-based language, should allow us to manipulate that string in multiple ways to ultimately get the data we're looking for out of that. Make sense? Okay, so this is us problem solving with this. All right, so we can use the scanner directly to read in a certain type. We can read in a Boolean, we can read in a double, we can read in all the different types are represented, all the primitive types, as well as strings are represented. Or we can just go ahead and read it in as a string and then manipulate it ourselves using the integer.parseInt. Okay. So with this example here, we're reading stuff in from the keyboard. I'll go ahead and comment that out. So we're reading stuff in from the keyboard here using the scanner. Now, this is that URL, the website that I told you about a few minutes ago, that has the wall of text in it that has our cards. Now we could go in and copy and paste that whole thing and bring it into our program like a string, and it'll be kind of scary. So I can go in here, I can select all, copy it, and I can say something like string card is equal to, I'll put a double quote before it, and I hit paste and it's figuring something out. Okay, so there's some gigantic long string and it's like overloading Eclipse. Eclipse is like super slow right now. This might even be too big for a string to fit. Okay, but even if it does work, probably not the way we want to do things. And also notice that we have some errors, even if I haven't put the semicolon in. Notice here we have all these, actually it did fix it. See the double quotes here? Double quotes are string beginning and string terminating characters. Eclipse did put backslashes in there for me to hopefully format it better. All right, but we're going to say that this probably is not best practice to hard code some giant string from online into your code, especially for something like this, where every single time they make an update to the game, presumably they maybe have made changes to old cards, added some new cards. We probably want to be pulling that data from the source every single time. So I'll go ahead and get rid of that guy. Okay, so that's not how we want to get that data. We instead want to somehow get our program to connect to this website and read that data in so that we can work with it. All right. Now we can prove that we read it in. So I've written a function here, and it's a static function called getJSON. And we'll look at that here in a second. But since it's a static function, how do we call it? We call it using the name of the class in which it was defined. Since I'm inside of the driver class, and I'm currently inside of a static method, which is known as a static context, I don't actually have to say driver dot, but I typically will say driver dot getJSON. This makes it easier for you to avoid spelling errors. In Eclipse, if you say driver dot, name of my current class dot, it lists the stuff that this class can do. One of them is this static method that I wrote that's owned by the class itself. So I can call upon that method. All right, so I'm going to go ahead and call my getJSON. I'm passing it a string. Let's go see what it does with that string. So here's my function called getJSON. The goal of this function is to open a URL and read its contents as a string. All right, there's plenty of ways we can kind of pull this off in different languages, but we're just reading it as a string and we're going to manipulate it ourselves because we're going to practice string manipulation in here. Okay, so potentially the website we're trying to go to might not exist. Somebody's sending us a string. We're going to try to go to that website. So this guy right here, when I try to open up my URL, that could give me an error saying this site doesn't exist. It's not loading, whatever. There could be issues trying to connect to a site. Just like if you go on a web browser and you go to a site and the site's currently down, it gives you some sort of error. In Java, they say, look, since this code right here could cause a problem, you should try to do it. And if you run into a problem, you can then catch that problem and do something else if you ran into the problem. So maybe I do something like line is equal to site, just can't connect, something like that. I'll do that. So if it works out, I'm going to do all this stuff. If it doesn't work out, I'll change line to can't connect. Notice I defined line before the try as an empty string, and I'm returning it regardless. So it's either going to return as the contents of that web page, presumably, I'll walk through that code in a second, or it's going to get set to can't connect, and I'll return that string. So let's see what happens inside of this try. So I'm going to build a URL object. So a URL object exists inside of java.net. So Java has a network library that allows you to connect to stuff on the internet and other networking stuff. So I'll use the URL object that already exists in there, and I'll create a new URL using the string that is the website, http://www, that stuff. Then I'm creating a scanner just like I did before, but instead of reading from the keyboard, system.in, I want to read from the input stream associated with my URL. So I ask my URL to open a stream. So I established a connection to a website, and then I opened a stream to that website, and then I wrap that with scanner to read from a stream, like we've already done. So now this while loop says, keep reading from the scanner as long as there is something to read. Keep reading from the scanner as long as there's something to read. We don't have a guarantee that it's going to give us all the data at once, because we're kind of at the mercy of the networking protocol that's being used, things like that. Okay, so I am reading effectively bytes over the internet. So as long as there's something else to read, as long as input has something else in it, I'll just take my string line and I'll concatenate onto it whatever I'm able to read. So this is going to happen over and over and over and over again, building up line to be hopefully the full contents of that URL. That make sense? As soon as I don't have anything else to read, I'll get past this while loop. As a good Samaritan, I'll go ahead and also close my input stream. Java will let you get away without doing this, but you finished a phone call and you just put the phone down and walk off. It's still connected, and then I can hear my mom talking over my.
Did you get up for class?
Yeah.
Okay, good.
Oh, that's great.
Just want to make sure. Okay.
It really was amazing for that example. Yeah, my mom doesn't know how to hang up a phone. So as I hear her talking to my dad or screaming at her plants, she does things. So in any case, typically when we're done with a phone call, we hang up the phone, right? Closing the connection. We should probably do the same thing here, so we're not relying on Java's extra stuff to go, and Java has automatic garbage collection among other things where it would go and it would eventually close that connection for you. It would clean up your mess. But as good programmers, we should really clean up our mess for ourselves when at all possible. All right, so keep reading in as long as there's something to read. As long as we're done reading stuff in, well, when we're done reading stuff in, we'll go ahead and close that stream. We've done reading from the site. We'll return the line that we read in. If something bad happened, we would have caught that exception, in which case we'll just set line equal to just can't connect, or whatever error message you want to put in there, something like that. Any way you cut it, we're going to return a string. We're either going to return the string with our stuff in it, or we're going to return a string that says can't connect. All right, makes sense what I'm trying to accomplish here in get.json. I'm still using the scanner, still doing that same stuff. So now up here, and that guy returns a string. Get.json returned a string. So I'm going to go ahead and I'm going to create a string. I'm going to call it card.json. This guy is going to be a variable that I'm going to use to catch whatever string my get.json function gives me. My hope is it gives me this big long JSON string, but it might give me a can't connect. All right. So right now I have the correct address in here, and I'll go ahead and try to prove that it works by afterwards saying system.out.println card.json. This might be a little slow because it was a pretty good size data, right? Probably a megabyte or more of data. But let's go ahead and run this. So it's delay, 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 boom. We get a dump to the screen. That's our big JSON string. Make sense? So we read that in from the internet, brought it into our program, so now we can do stuff with it. All right, now let's purposely break this. I have a spelling error, typo there. So this is not a good address, right? So if I run this guy again, it's going to have an issue. And so I got my can't connect here. But if you look down here in my code, I also did something called a print stack trace. It tells me what went wrong. So notice this error here. It says java.net malformed URL exception. I don't know what that is type thing. Okay. If I break it in a different way. So let's maybe just change the name of the file I'm looking for. I should get a different error this time. File not found exception. Couldn't find the thing I asked for. I established a connection, but the web server yelled back and said, look, I've never heard of cards.jso. All right, make sense? So that's how that exception handling stuff works. And we'll see examples of that, but Java allows us to try to do something, because some things force us to do this. If I did not put this code, I think it's that one, inside there, if I put it out here, notice if I highlight over this, it says unhandled exception, type malformed URL exception. That particular constructor, the for URL, it says something bad could happen when you try to use this constructor. You have to deal with this one way or another. Does that make sense? So probably the best way of dealing with it is for me to write my own code to try to do it, and then write my own code to potentially catch the error. But I could go ahead and say, look, I'm not going to do anything about it anyways. So I'll just make this method throw an exception. It's like, oh, something bad happened. Pass the buck. Whoever called me is going to have to deal with it. But now we got to scroll up, and we see that now we have an error up here. It's like, look, there's an unhandled exception. This method, get.json, throws an exception. Why? Because I just wrote it. I tried to be lazy. So it threw an exception to where I called it. So I would have to do a try catch in here. Or Java virtual machine. Look, I don't want to write exception handling. Anything bad that happens, you deal with. Make sense? So you can pass the buck all the way to the top until finally you just say, look, I'm not dealing with this in code. If you're going to crash, you're going to crash. You can just give me the error message. Now, the punchline there is, as good programmers, we probably want to deal with those things locally, even if we're not going to make an exception. Exception handling gives us the opportunity to, I don't know, let's say, either recover from an error, or crash gracefully, something like that. Maybe we, currently have a bunch of files open and we go ahead and we say, well, let's go ahead and save and close these first before we just die. So exception handling is a good thing, but it does require a little bit extra effort of us writing some lines of code that really we don't intend to ever get called. We hope everything goes to plan. We don't have errors, but sometimes your internet's down, something like that. You've seen it. You're watching Netflix and it says, we're having trouble loading this content right now. Sometimes that means your internet went down or something like that, or who knows, maybe it was a Netflix issue, whatever it was, but exception handling happens all over the place. So we're going to call this bad programming practice. We're going to call this bad programming practice. And because we know it could cause a problem, we'll go ahead and do our own try. We've really already cheated a little bit, because instead of, because you can have multiple catches. You can say, well, here's one catch for a malformed URL exception. That's what I want to do for that. Here's another catch for a file not found exception. I can do something for that. But instead, what I did here is I just said, look, if any exception occurs, just do this crap. At the very least, I've told Java, I know something bad could happen. I took care of it. Don't worry about it. What I'm actually doing is kind of on me. Make sense? And Java's happy to yell at you, and Eclipse will give you the little red squiggles. Hover over it, get used to reading those messages. If it says uncaught exception, then I probably need to do a try catch here. All right, so we saw a couple different errors that we introduced there, but in the end, if we give it a good URL and our internet connection's alive, so you potentially could take my code and run it and it won't work if you're not connected to the internet, right? Okay, but my internet connection is presumably alive right now. So I'll go ahead and run my code, and I should get after a couple seconds of reading it down, my big JSON string. Make sense? Okay, so let me go ahead and this is our code, right? So I've made a change to source driver. And I'll go ahead and say updated for reading JSON from web. I'll commit that locally. I'll say push origin. So it's up there. So for your homework, get your own local copy of my code that reads from a website into your program. If you want to read from a different website, that is fine. Perhaps there is a data source out there that matches what you did in your previous assignment if you selected a different hobby. Okay, I'm not forcing you to mimic my Hearthstone example, but if you're a fantasy football fan, I'm sure you can find data sets for football players and stuff like that. Heck, actually, with the code we have written right now, you could just put in Google's website and it'll just download the HTML from it. All right, so I'll put the link up. I'll put the homework up. I'll remind you of the link from GitHub. It was in the previous one, and it's on Slack. But get a version of this working so that for your next homework assignment, which we're going to be parsing through this string and doing some stuff to it, you have something that's reading from the internet. Questions, comments, concerns, bribes? All right. And like I said, if you have problems with your GitHub, I'll be in my office for a few minutes right after class here, but otherwise, catch me on Slack and we can just do a quick Zoom thing and I can remote into your machine and see what's up. It's probably, almost all of them are fixable like in 3 minutes. Okay, it's probably one little step you're missing or something like that, but don't wait till 4 weeks later before you say, oh, I can't submit my homework with GitHub. Make sense? All right, have a good one.